my dear student, I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the topic of wave for the subtopic of the wave motion. So, my dear student, before we proceed with our discussion here, we are supposed to remember where we ended on the last session. On the last session, we tried to explain some examples related. How can we find either the number of harmonic? How can we find the fundamental frequency? What we tried to discuss on the last session. But for our today discussion, my dear student, we are going to proceed with our examples here. This will be the last session for this subtopic, which is called the wave motions. As we observe our example number 8, my dear student, for the topic number 8. Our example said that a string of a length 2 meters. We have the string, and that string contains the length of 2 meters. And having the mass of 6.0 exponent -4 kilogram is fixed at the both ends. This strain is fixed at both ends. The first point is fixed at the first end and also on the second end, as we have been told here, my dear students. So it's under the tension of 20 Newton. Now, if it is plugged in, now we have been told that ile tension yake iliyobini formed pale ilikuwa ni sawasawa na 20 newtons. But it is plugged at a point 20 centimeter from one end. Ilibini plugged at the 20 centimeter katika one end, as we have been told, my lovely students. What will be at the frequency of vibration of the string? How can we get the frequency of a vibration of the string, my dear students? This is what we have been asked on our discussion here. So the thing that we are supposed to do first before we start solving this question is to summarize the data that we have on our equation here. So on our equation we have we have the length of the string, because we have been told that the string contains 2 fixed points. First of all, it is fixed at the one point, and also it is fixed at the other point, and it was tried to be plugged kama tulivyoambiwa. Now, after being plugged, it tried to form the tension which is equal to 20 Newton, and also we have been told that from one end it is a length is equal to 20 centimeter. This is like the wavelength, I think. So what will be the frequency of vibration of the string? How can we get the frequency of the vibration of the string? Let us summarize our data kama tulivyopewa kwenye swali letu. Tumwambia sasa kwamba the data that we have on our equation here is the length of the string, which is equal to 2 meters. Also, we have the mass, which is equal to 6.0 exponent -4 kilogram. And also we have the tension which is equal to 20 Newton. Also we have this value at 20 centimeter. Now, how can we get the frequency, as we have been asked the frequency of vibration of the string? So first of all, let us say that the plugged string will make the antinode A. Kwa ile fixed string after being plugged itaweza kutengeneza antinode A kama tulivyoambiwa hapa at the plugging point, and each end of the string will be an node, lakini each point itakuwa ni node kama tulivyoambiwa kulingana na maelekezo yetu hapa. So after there, my dear student, we have been told that the AN means the distance between A and N. Kwa huyu AN ata-imply the distance between the antinode and also the node. It means the node. Kwa AN atamaanisha the distance from the distance that is formed between the antinode and also the node is expressed by the AN, my dear student, and it is given by this one as we observe here. We should express the distance between the antinode and also the node by saying that this would be equals to the wavelength of the enharmonic divided by 4. Kwa ndo formula yetu itakuwa ni sawasawa na wavelength divided na wavelength of the enharmonic divided by 4. But we know that this wavelength of the enharmonic must be equals to 2L. Kwa hiyo distance yule wavelength wa enharmonic atakuwa ni sawasawa na 2L, lakini huyu atakuwa ni sawasawa na 2L divided by n. Kwa hiyo tutamsubstitute pale this wavelength of the enharmonic which is equal to 2 times the length, then we divide by the 4 times the enharmonic, my dear students. So where this why we say that we substitute this 2L divided by n is because this wavelength of the enharmonic is equal to the value of the 2L, then we divide by n. Kwa tukisha substitute hapa tutampata kabisa kwamba kumbe huyu an ambao ni distance between the antinode pamoja na nodes atakuwa ni sawasawa na 2L. It means kwamba must be equals to 2L, then we divide by 4n ambao n atakuwa ni number of the harmonic, lakini yule L ata imply the length of the wire as we have been told. So after there we should make n as the subject. Kwa tutajaribu kutafuta n as the subject, my dear student, by crossing here by putting here, by taking the relationship an is equal to 2L divided by 4n, then we put over 1 hapa, then tuka cross multiplication, tunamfuta huyu wa katikati. Tukishafanya hivyo tutamake n as the subject, na huyu number of harmonic atakuwa ni sasa kuchukua the length, then we divide by the 2 times this distance between the antinode and also the nodes. Na mwisho wa siku tutajaribu kusubstitute kusubstitute data ambayo tumepewa kwenye swali, kwa sababu tumepewa huyu distance between the antinode pamoja na nodes ambaye ni sawasawa na 20 cm. Kwa hiyo tutamconvert kumpeleka kwenye mita. Tukishamconvert kumpeleka kwenye mita, mwisho wa siku tutasubstitute sasa kwamba palipo na length ya string tulipewa ni sawasawa na 2 meter. Kwa hiyo tutaiweka pale the length of the string which is equal to 2 meter. And also we should substitute the distance between the antinode pamoja na yule anode ambao itakuwa ni sawasawa na 0.2. After there we should simplify. Utakansel kwamba let us for 2 because at the numerator and the denominator we have the same value, tuna 2 hapa, kwamba tutakansel yule 2, mwisho wa siku itabakia ni 1 over 0.2. 1 over 0.2 ukigawanya pale utapata ni sawasawa na 5. Kwa kumbe the number of harmonic, my dear student, must be equals to 5 as we have been given on our equation here, my dear students. So therefore we should say that the string will vibrate in the third harmonic. Kwa sababu tumepata yule number of harmonic ni sawasawa na 5, basi tutakuwa tumeshatambua kabisa kwamba huyu hii kamba itaweza kuvibrate kwenye third harmonic, it means kwenye second overtone. Sasa tutaliko ile formula ya ile third harmonic, it means ile formula ya kutafuta frequency kwenye third harmonic ambayo tunaijua kabisa kwamba frequency of the enharmonic is equal to n divided by the 2L times the radical of the tension divided by mu. But here we are talking for the third harmonic. Kwa kama ni kwenye third harmonic the number of harmonic is equal to 5. Tutamweka pale kwamba palipo na n tutaweka 5. If we substitute the number of harmonic is equal to 5, my lovely student, we should obtain that my dear student, we should obtain that this frequency of the frequency of the third harmonic must be equals to 5 divided by 2 times the value of length. Tumesubstitute value of length ambayo ni sawa na 2, and after there we multiply by the radical of the tension. Tension tunayo ni sawa na 20 Newton. then we multiply it by the length, kwa sababu huyu mu huyu linear mass density ni sawa na length divided by the mass. Atapanda juu, akishapanda juu tutaona kabisa kwamba kumbe atakuwa ni sawa na 2 divided by 2 times 2 meter, then we times it by the radical of 20 Newton, then we times it by the 2 meter, we divide it by 6.0 exponent negative 4 kilogram, as we have been given, my dear students. So finally we should conclude by saying that according with the way that we have been asked on our equation, we should say that the frequency that could make this wire to vibrate, this string to vibrate, might be equals to 2.7 hertz. Most of them they asked that how this answer become. This answer become after simplifying, after taking this value. You have to take this value and substitute into your mathematical calculator. Finally utaweza kupata hili jibu ambalo tumelipata ni 322.7 Hz, ambao ndio frequency ambayo tuliulizwa itakayofanya ile string iweze kuvibrate katika kuweze kuvibrate kwenye for the 5 for the number of harmonic which is equal to 5. So after there, let us after there, my dear student, let us stop here. We should come and proceed with the next part.